Hey everybody, and welcome back to Korb Stat Chat. So in this episode, what we're going to be talking about is distribution shapes. Crazy. Okay? Basically, distribution shapes are just a way that we can describe data. So especially if we have histograms, which you can see here, which I've done, which span an interval, which gives us shows the frequency of data over specific intervals called classes. And that's what we're going to be talking about here. So we want to be able to describe our data in ways that we can sort of translate and start making inferences on based on the population that we selected the data from or collected the data from. So we're going to go through each of these. I'm going to switch over to a screencast here momentarily, but we're going to talk about symmetrical, we're going to talk about mound shape. Later on in the course, we're going to be talking about the empirical rule, which corresponds to standard deviation on the normal distribution or normal curve, which is going to look very similar to this distribution right here. But we're going to talk about all of these. We're going to talk about skewed left, skewed right, bimodal, all these various distribution shapes. And then throughout the course, we're going to be referring back to these because we want to be able to describe the data as best as we can in our descriptive statistics, which will lead into our inferential side of the course. All right, so let's switch over to the screencast and talk more about each one of these various distributions. Okay, so let's talk about the histogram a little bit more and talk about histogram distributions. I just introed this video with just a little snapshot of all the distribution shapes that we're going to talk about. These aren't all of them, but a large majority of these are the basics. So let's talk about these distribution shapes and how we can describe data. So this first one is the mound-shaped symmetrical. It's symmetrical because if you split it down the middle, it's equal on both sides. You can have near symmetrical, which is just very close to being symmetrical, so you can describe the data that way, around the center. You can also describe this as mound-shaped and also normal, because we have equal on either side. We're going to talk about the normal distribution later on. Not particularly this, but we'll talk about how percentage-wise, using the empirical rule, how many standard deviations away does X percent fall into. Okay, so again, different video, different time. But this is the mound-shaped symmetrical. This is the most normal that you can get. So again, mound shape. Uniform or rectangular. This means that every single frequency has the same level of frequency. So every single interval is exactly the same. This is called uniform or rectangular. It's also symmetrical, obviously, just because on either side there's going to be an equal amount. But again, frequencies are all going to be the same in this case. Skewed left and skewed right. The one on the left is skewed left. So all of our data, sort of the higher end of our data is to the right end of this graph. And if we were to, if you could follow my mouse, if we were to draw a sort of a curve here, we can see that it's going to be skewed left in this case. So all of our data is flowing to the right. And then skewed right, it's just the opposite. So all of our data is sort of thrown to the left side of our picture here. So it is skewed right in this case. Skewed left and skewed right happens quite a bit. It's fairly common, so we'll be seeing those also. And especially when we get into some stem and leaf plot distributions, we'll see on the stem and leaf plot skewed left and skewed right. These are just different ways to relate the data. So we know that the higher frequency on the skewed left is to the right, and the skewed right is to the left. So typical bimodal, bi meaning two, you'll see that there's two sort of higher frequencies here. It just splits the data into sort of two humps here if I would draw an imaginary line right above it. So we have a typical bimodal. One thing I do want to show you is this website here, Shodor Math. It's great for interactive. You can see a lot of cool things on here. But I wanted to show you what happens when I increase the number of classes for each frequency. Okay, so taking a look here, this is, again, that website I was talking about. Really, really cool tool here because we can actually import our own data to create our own histograms, or they already have these pre-made ones, which I'm going to go through just a couple. But what's really neat is if I slide this across, I'm going to increase and decrease the number of classes that I have. So when I have very few classes, it's kind of hard to see what my distribution shape is going to be until I start backing my way out. So this one, it's definitely going to be skewed right. You can see all the data is on the left-hand side here of our chart, but it starts to become a little bit unclear, probably like right in here. You can still see that it's skewed, but you don't really know until you max out your classes. And if I would keep going out, who's to say that this isn't a little bimodal as well? So the more classes, the better. The only reason that we don't use a maximum number of classes is because of time and resources, right? So in this case, you can see out of 173 numbers in this set, this is the distribution curve. So let me back this out somewhere, yep, right there, and then I'm going to go to a different one. Let's talk about horsepower of cars. Again, you can see sort of a curve here with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 classes here. Well, let's back this up a little bit, and so we'd say that this one might be skewed right. Okay, I just keep going, but now I can see that there's this big spike here between this 133 and 182, so that frequency is a lot higher. So this one might be bimodal as well, but typically it's going to be, this one it would be bimodal skewed right. But if I don't do that, it would just be skewed right. So you can see how the number of classes is going to affect your distribution curve. Let's switch here. Let's talk about body fat. This is of 252 men. So this one, fairly symmetrical, right? Mound-shaped. So I can describe the distribution shape as that. But if I would back it up to 2 classes, you can't really tell what it is, right? Or even let's go to 3 classes. You really can't give a good accurate representation of what this data is because right now it looks skewed right. But again, more classes the better. So if I bump the whole way out, man, that's fairly mound-shaped. That's pretty much symmetrical. So this is going to be our normal distribution curve. And body fat or just weight in general, ages, heights, all that stuff are going to fall into this category. Let's look at 1 or 2 more. Let's talk about this one as I back my way out. This is spending per student in some schools. Again, if I just fluctuate between the number of classes that I'm using, you can see that the distribution shape does change quite a bit. And again, gas mileage for various cars. Okay, so again, you can see the curve that changes the distribution shape. So number of classes really does affect the distribution curve. And we're going to do this in our calculator where we generate a bunch of different histograms, and we're going to compare the different histograms that we create of 5, 10, and 15 classes and see what the real distribution curve is. If it all stays the same, or if there are variations between the 3. It's really cool to see what happens to the data when you start increasing your classes and decreasing your class widths. All right, so thanks for watching. This has, again, been Mr. Korb with #KorbStatChat. Hopefully this has been beneficial for you, that we've gone over some of this topic in depth. If you have any questions, shoot me an email, send me a tweet. However you want to get in contact with me is great. All right, peace out. I'll talk to you next time.